Hello, I welcome you all in this course on refrigeration and air conditioning. Today we will discuss indoor environment health. In today's lecture, we will cover health problems in indoor environment health, indoor environment, airborne contaminants and gaseous contaminants in indoor environment. Uh, so indoor environment health, indoor environment health it covers those aspects of individual's health which are affected by the indoor environment. So it is more concerned about the health of an individual. If the indoor environment is not healthy, is sick, then definitely the occupants are also liable to fall sick. Now, health problems, we should understand health problems in indoor environment. Health problems in indoor environment. Now, health problems in indoor environment, with the most common indoor environment health problem is asthma. Asthma, it is normally due to dust mites and smoke, tobacco smoke. So asthma is one of the problem which comes in the controlled environment. That is, another is allergic rhinitis. In this is also by pollen and dust mite. Okay, so in this disease, there is a stuffed nose. You must have observed that when you are sitting, sometimes when you are sitting in air conditioning environment, you have a stuffed nose. When you go out, things become okay. Now, third one is contact dermatitis. This is due to in this disease there is a dry skin and itching, dry skin and scales on the skin are formed. So this type of disease also may take place if the indoor environment is not healthy. In addition to this, eye irritation, eye and nasal irritation. Further, we can take here. There is a disease which is known as Legionnaires' this spread through bacteria and it has pneumonia like symptoms. This is a very serious, deadly type of disease, and it has symptoms like pneumonia and fever. Organal dysfunction can also take place, and this is due to the bacteria. This bacteria grows in the fresh water. So the favorable ground for this bacteria is condensate water in the air conditioner or in the cooling tower. Especially in the centralized cooling system, you will find that there are number of cooling towers which are used for the purpose of cooling water in a condenser. So there also this bacteria can develop, and infection with this bacteria causes this disease. And in this disease, there is a high fever, and organal dysfunction can also take place. Now, in addition to this, there is a Pontiac fever also. Pontiac fever, it is flu-like illness. So when the environment you are sitting, you feel that you have you have been infected with the flu. So these are the diseases. They are some of the diseases, not all the diseases. They are some of the diseases which you may catch up when you are sitting in a controlled environment. So you, as a person, you should know all about these diseases because they are coming from the controlled environment. Sometimes what happens, we catch up some disease, but the source of disease is not known to us. So for these diseases, the controlled environment can be one of the source. Now there are number of contaminants in the controlled environment which affect the environment health. And number one is airborne contaminants. Airborne contaminants. In airborne contaminants which are spread through the air, they are particles and particles of dust. Normally they are of dust particles ranging from 0.1 to 100 microns. Smoke particle size is particle size is approximately 25 microns. Micron is 10 to power minus 6 meter. And fumes, the size of the fumes is approximately 1.1 micron. Now dust is major constituent of airborne contaminants, and the maximum permissible amount of dust which one can take in with the breathing is approximately 15 mg per meter cube. So this much amount of dust in the air is permissible. Actually air should be dust free, but it is, if you want to have dust free air, a lot of arrangements have to be made. Then you will have to go for a clean air and filters have to be provided. But if the presence of dust is approximately less than 50 milligrams per meter cube of air, it is accepted for normal air conditioning, not the special type of control environment, but normal air conditioning, it is acceptable. Bioaerosol are also there. In this bioaerosol comes the molds. Mold is a major problem in air conditioned system. It is a sort of fungus which has filamentous structure, and it develops in the confined space, air conditioning space. You must have also seen in those systems which are centrally air conditioned and they are air conditioned for a long time along the wall or in many of the places or inside the duct also, the mold develops. So this is a very common problem in air conditioning system. So these airborne particles, they consist of bacteria, fungals, protozoa, algae, and combination of these. Now after airborne contaminants, there are gaseous contaminants which affect the indoor environment health. Gaseous contaminants. Now gaseous contaminants are mainly VOC. This is volatile organic compounds. Now volatile organic compounds are very harmful to the human health, right? So in any building, especially where volatile organic source of volatile organic compound is there, so they have to be removed. They make the air sick, and number of volatile compound, for example, 4 to carbon, alkanes, different type of organic alkanes, alcohols, then alcohol. aldehydes, ketones, esters. So there are many chemical this organic compounds, and these volatile compounds, their vapors, when they are mixed with the room vapor, it it affects the quality of air which is being circulated in the room. Now third one is gaseous air contaminant. The second one is gas inorganic. Now the gases, this is organic, 2A, these are organic, and some are inorganic gaseous compounds. So 2B, inorganic. So organic gaseous compounds, that's the volatile organic compounds. Then inorganic, in inorganic, the first and the foremost is carbon monoxide, ammonia, carbon dioxide, ozone, sulfur dioxide, and many more. Now carbon monoxide, which is odorless and colorless gas, if the concentration of permissible concentration of carbon monoxide is 50 ppm parts per million. So carbon dioxide in the air should not be more than 50 ppm. Carbon dioxide can go up to 400 to 500 ppm, 400 ppm parts per million, and it can go up to 700 also. Outside air nowadays in the metropolitan cities, outside air is quite polluted, so it can go, but in any case it should not exceed 1000 ppm, because 1000 ppm then it will make it will affect the health of indoor environment, and it will make the air sick inside the room. Now nitrous oxide, there is one inorganic compound is nitrous oxide. So nitrous oxide is also, if there is a 3 ppm of nitrous oxide, then it is equivalent to the exposure of 10 to 15 ppm carbon monoxide. So it is more fatal than carbon monoxide. It is, we can say 15 times. It is only 3 ppm is permitted. For carbon monoxide, it is equivalent to 10 to 15 ppm of carbon monoxide. Nitrogen dioxide is also is one of the inorganic air gaseous contaminant, that is nitrogen dioxide. And nitrogen dioxide threshold is between 0.11 to 0.22 ppm. It is not soluble in water. So nitrogen oxide, when it is inhaled, it is not absorbed in air pipe. It is not absorbed by the walls of air pipe. It goes deep into the lungs, and it has delayed respiratory response. So suppose you inhale the nitrogen dioxide, the respiratory response will be delayed for this, because it is not absorbed by any part of this, either for air pipe or the lungs. But if it is settled in the lungs, then it will show the symptoms of delayed respiratory response. Now another gas, that is sulfur dioxide and ozone. Sulfur dioxide is 0.5, not more than that, ppm. This is permissible. For ozone, it is very interesting that it is 20 parts per billion. It should not exceed. So ozone is also, very dangerous gas. It is 20 ppb, which makes it fatal. That is why it should be below 10 ppb. So these are the certain chemicals which creates health problem or which pollute the indoor environment. Now in addition to this, now these airborne gaseous particles or gaseous particles, electric hazard are also there. Electric hazard. This has to be taken care of in the building. If 100 milliampere, this is an interesting figure. If 100 milliamperes of current is passed through heart for 2 seconds. In that case, fibrillation of the heart will take place, or heart muscles will fibrillate. Fibrillate. Fibrillation means the muscles will strain with each other, and the heartbeat and pulse, they will go out of rhythm. And this happens with the ventricle of the heart. Ventricle is the lower part of the heart which pumps the blood in the body. So when the pulse and the heartbeat, they go out of rhythm, the pumping problem arises, and that is a very serious situation, and this can be fatal also. Now, second thing is the major part of the thermal resistance, because our body fluid is a saline fluid. So, major part of thermal resistance come from our skin of an individual. So, if skin is wet, right, its conductivity increases. So, care has to be taken in a building, so in a confined space, not only air, but electric fitting also, they should be properly insulated. Otherwise, this may cause a serious problem. So, we don't require very high voltage or very high current to be fatal. Even this much of current is passed through the body, I mean from top to bottom, then this can cause serious accidents. When your skin is low, even the voltage of the order of 2 volt DC, or sorry, 2 volt AC and 5 volt DC can be detected from your skin if the skin is wet. So, in this case, so if this happens, if the heart vibrate, proper medical aid is required to be given to the patient. Patient becomes sometimes subconscious or sorry, unconscious, and immediate medical help is required by the patient. Now, indoor health environment, odor is also one of the factor. Odor in the air. Now, source of odor in the air, sometimes you enter a closed environment, the temperature is okay, humidity is okay, air movement is okay, level of oxygen, everything is okay. But if odor is there, you don't feel comfortable. Now, this odor is due to ammonia and hydrogen sulfides normally, and some of the VOCs, volatile organic compounds, they add to the odor in the system. So, in any system, minimum ventilation is required, a minimum level of ventilation is required to remove the odor from the system. So, there are certain olfactory stimuli. Olfactory stimuli means those substances which stimulate the sensing of odor by the nose. So, these stimuli are any organic substance which is having molecular weight more than 300, it is normally odorless. So, if any organic substance is present in the air which has molecular weight more than 300, it is odorless. Some of the substances having less than 300 are also odorless. That is one thing. There is a chemical trimethylamide, this is trimethylamide, and it gives the feeling of fishy odor at the concentration of 0.1 ppb. So, parts per billion. So, for such a low concentration, this chemical will give fishy odor. So, like this, there are number of chemicals, right? Some of the chemicals, it is possibility that some of such chemicals are mixed in the air, but in any case, in order to get over this problem of odor, a certain level of ventilation has to be maintained in the building. There is a threshold value for chemicals. There is a regarding the odor, there is a threshold value in ppm. I will write to for example ammonia. Ammonia has to be less than 7 ppm. in the air. If it is more than 17 ppm, uh, you can feel the pungent smell of ammonia. Chlorine. Chlorine has to be 0.08. Methanol, CH3OH, methanol has to be 160 ppm. If it is more than 160 ppm, you can feel the odor. Phenol, 0.06. Likewise, for all chemicals, possible chemicals, there is some threshold value. So the presence of these chemicals in the atmosphere, if it is less than these values, you will not feel odor of these chemicals. Another thing which disturbs the indoor environment health is noise. Further, if the temperature, humidity, air movement, everything, even odor is controlled, if the noise is there in the occupancy, in that case, you will not feel comfortable. The occupancy means now it is expressed in noise is expressed in terms of decibel, right? If somebody whispers, though, I'll give you some idea, it is approximately 10 decibels. I am just talking to this room, the sound may be order of 60 decibels. But the moment you reach 100 or 120 decibels, it is a logarithmic scale. So the moment it is doubled, I mean 120 decibel, it becomes unbearable. It becomes a jet voice. Noise of 140 decibel can damage the ear. It can damage the ear. High decibel noise can even damage your skin, it can damage your heart, it can damage your respiratory system, affect the respiratory system. So noise, so these order of noise are not there in air conditioning system, but the noise level is low. I mean, noise level should not be more than 40 or 50, so that the occupants remain in a state of comfort. This is all for today's lecture. Tomorrow again we will take indoor environment health. Thank you very much.